Hello, in this video let us take a look at what recursion is and how we can implement recursion in the Python programming language. Now this video is aimed at absolute beginners who are just beginning to program and who want to understand how recursion works. So in this video we'll be using an IDE, specifically Visual Studio Code, and which will help us to understand the steps by which a recursive program is executed by the programming environment. Now let's get started. For this example, let us start with something which is very simple. The simplest program for exhibiting recursion, which is usually taught to most beginners, is how to find the factorial of a number. A factorial of a number is nothing but the number multiplied by its predecessors till the value of 1. So if we want to find out the factorial of 5, it means 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. And let's start with this. Now first let us have a definition of a function. Let us call it factorial. Now this factorial will take a value of n. Now this is what we want to compute the factorial of. The first thing that I want to do is to tell it what I need it to do. So what I'll say is I need it to compute n, multiply it by the factorial of the number which is less than 1 less than it. Now if you look at 5 factorial, let me put it into the comments here. What we want is 5 factorial is equal to, I need 5 which is n multiplied by a number which is 1 less than it, which in turn is nothing but the factorial of 4, which is again multiplied by 3, is again the factorial of 3, then I again want it to be multiplied by the factorial of 2, which is nothing but 2, and then multiply it again by 1. So now when you look at this string, what we understand is for us to get the factorial of 5, we need to multiply 5 with the factorial of 4, which is represented by this particular string, the highlighted area. And for you to find out the factorial of 4, you need to find out 4 multiplied by the factorial of 3, which is represented by this particular highlighted area. And likewise on and on. 3 multiplied by 2 factorial, which is nothing but 2 into 1, and finally 1 factorial, which is nothing but 1. There's a 0 factorial as well, which is nothing but 1. Alright, now what we need to do according to this is, I have 5 right now. I need to get 5 into 4 factorial, which is nothing but factorial of n minus 1. This is what I want, right? Now this keeps on repeating again and again and again. But what when I reach 1, or what if I reach 0, when n minus 1 becomes 0? N is equal to 1 and n minus 1 becomes 0. So I need to handle that. So what I'll do is, first I'll check if n becomes 0, what do I want? I want it to return 1. Why? Because this is a multiplication and returning 0 will cause the entire string to become 0. So what I'll be doing is, when I hit 0, I'll be returning 1. Great. So if it is not 0, till that point, keep doing this. Let me intend this to put it else, right? What happens here? When it is not 0, 5 becomes, when it is n is equal to 5, 5 into factorial of 4. Go back here. When it happens, then n becomes 4. If n equal to 0, no. Come back here. So now it becomes 4 into factorial of 3, and so on and so on and so on and so on. So what we need to do is make sure that this returns this value so that we close the entire loop. Now let's try to quickly call this within a main method. If let me print it, print factorial of 5. Now let's see what happens? Let me open a terminal here and say Python recursion. There you go, 120. Now let's quickly try to see how this entire recursion happens. Let me put a breakpoint here and let's start debugging. Now this is something which we are not really looking at. Let us take a quick look at what is happening in the call stack, which explains what are the different calls that are being made, function calls that are being made. And let us look at these variables, which are going to be showing the current values of each one of these variables, that is n and so on, as well as what got returned in some of these functions. Now let me step into this first one. Now we have n equal to 5. We're just starting it. It checks whether n is equal to 0. It is not. So what it does, it immediately goes and comes into the else clause. Now here we are trying to call factorial within factorial, which is what makes it recursive. But this time we are going to be passing n minus 1, which is 4, to the same function. Now take a look at the call stack. So here the main function had called the factorial function once, and now the factorial function is going to call itself again. Now let's see what happens when I go inside this. The call stack immediately increased by 1 and it's again calling itself, but this time it is calling it with the value of n equal to 4. Again it checks whether n equal to 0, no. So it goes back here and again it goes in, goes with factorial of 3, which is what we see here. And then again there is one more call stack which has been added here, and again we find that it comes here. Again we go inside and does call stack of 2, n equal to 2, and it adds one more to the call stack here. And again we go around and then we again go back here and becomes 1. One more got added. So which means this function has to return, the value will be given to this call stack, and from here it will be going to this particular stack value, and from here it will be going to this stack value, and here it will go to the output of this will go to this stack value, and finally the answer is going to be returned to the main module which has the print statement, which actually finally prints the value. Right? We are here right now. Let's quickly go through the next step. And this time we have n equal to 0. So this is we have reached the end of our multiplication. So what we have said is we needed to return 1. So now what happens? Now look at the call stack carefully. When we have n equal to 1, it immediately reduced it by 1. The call stack reduced by 1 and came back to the line which actually called this factorial function in the first place, which was the recursive call which happened before this. And here n was equal to 2. So what happens now is we already have n equal to 2. We have n minus 1 returning. Look at the first line here, returning a value of 1 because n equal to 0 returned 1. So now we are going to do n into the return value, 2 into 1, which is what is going to happen now. So now the factorial stack has also been reduced by 1, which means that it has gone back to one more previous step where the factorial had been called itself, but this time it has returned the value of 2 where the n was 3. Again it's going to multiply the return value, which is 2, with the current value of n, which is 3, and return 6, which is what we are seeing here. And when it returned, the call stack also reduced by 1, because as and when the recursive calls keep returning, this is finally a stack. We understand that a stack pops whenever we have a value which is removed from it, and as and when it keeps popping, the value that was actually stored when the call was actually pushed, the recursive call was actually pushed, is going to be retained, and which is what is being seen here as n equal to 4. The return value of 6 is now going to be multiplied with 4, which is the current value of n at that point in time, and we get 24. And again 24 is going to be multiplied with 5, and this is going to be the last step in the call stack, after which it is going to be returned to the main function. There we go. So by this time, what has happened? It has now multiplied it repeatedly. Instead of us calling a for loop or a while loop, a function has been calling itself repeatedly and finally been able to calculate the value of 5 factorial. And finally, when we run this, it produces a value of 120. This is what we see here.